Hi, everybody, and welcome back to Tech Unveiled and the 5th episode of the Cloud RAN series. So this is the place where we let our experts unveil more and share their unique views and insights on these upcoming technologies. I'm Sten, and I will be your host today. And we are going to dig into RAN automation and programmability. More specifically, something called non-real-time RICs, and that in itself stands for non-real-time radio intelligent controllers. Luckily, we've got two brilliant minds to help us get through all this. So let's start. Erik Westerberg, Chief Architect at Networks, welcome.
Thank you.
And also Matteo Fiorani, a Strategic Product Manager at Cloud RAN Product Line. Welcome to you too.
Thank you, Sten.
We're going to untangle the concept of a non-real-time RIC today, right? But before we do that, could we just start by talking about the challenges that we see as networks become much more sophisticated now than they've been previously, right? Would you like to start maybe, Erik?
Yeah, sure, Sten. And I mean, as we speak in the networks all around the world, there are literally tens of millions of decisions being taken every second about which user to schedule, which frequency to use, which transmission points to use. And traditionally, we have micromanaged the RAN in these decisions by setting configuration parameters. With 4G, and even more so with 5G, this just becomes too complex. Yeah. It's virtually impossible for humans to understand all the effects that you get from changing a single parameter. What you want to do is to tell the RAN what to do, but not how to do it. And this is what we call intent-based management. So you send intents and policies and information to the RAN so it knows what to do, and then you let it do its stuff.
Yeah.
And not only do we think that intent-based management will reduce the cost for operating the networks, but it will also lead to better end-user experience.
But how does then this non-real-time RIC help with that all complexity?
Yes, so with intent-based management, you want to tell the RAN what to do, but not how.
Yeah.
But the what is typically associated with a lot of contextual information. You may want to know which applications are being run and by who. If there is a problem in the transport network that you should be aware of, you want to know that too. And this is exactly what the non-real-time RIC does. It gathers all this information from various parts in the network, and then it makes decisions and guides the RAN with policies and information over these new set of interfaces. And it does it per UE, and it does it fast. It takes less than a second to react to what happens.
Wow.
And this is something that we haven't had in the system before. So this really brings new capabilities and new use cases, which we are really excited about.
So how do we see that the service providers and their networks will benefit from the non-real-time RICs, for instance?
Yes, so maybe, Matteo, you want to have some ideas on that.
Absolutely. The non-real-time RIC enables for a multitude of new use cases. It allows the RAN to optimize its behavior based on weather conditions. The RAN can prioritize the lower frequency layers so to maximize spectral efficiency in case of rainy conditions. It allows for a joint orchestration of RAN, transport, and core network resources to ensure end-to-end service quality. It also allows the RAN to optimize the configuration for high-speed users when being deployed next to a highway or a railway. These are just examples. The non-real-time RIC can do much more.
Incredible. So if you combine intent-based management and the non-real-time RICs, these can be quite powerful tools to support use cases in a more agile way than we've seen before.
Exactly.
All right, so let's dive into the nitty-gritty, right? Can you try and explain to us, from a technical and architectural perspective, the non-real-time RIC? Erik?
Well, sure, Stan. So to give you a picture, I thought it was easiest maybe to show you a picture. So I brought with me a piece of architecture that I work with in my daily work. Don't panic. It's quite simple. I will take you through it. What we're looking at here at the bottom is the ODU and the RU. And the DU is the software that makes the radio scheduling decisions, coding scheme choice, etc. really fast. You have the RU, which is the radio that you put in the tower, that radiates the radio channels and receives the radio signals from the UEs. And above that, we have the OCU and the near real-time RIC. And they are responsible for handovers, for bearer management, and the like. And these three entities together make up the RAN itself. At the bottom, we have the cloud, the infrastructure. It could be physical hardware, or it could be virtualized hardware. And at the top, we see the management system, or rather, a more powerful version of the management system, because we have added in the non-real-time RIC here. Connecting all these pieces, you see these lines or interfaces, as we call them, which are how the different parts communicate with each other and send signals and messages between the different entities of the network.
I do notice that we've got two different RICs in the picture. What's that all about?
Maybe I can help with that, Sten.
Please, Matteo.
The near real-time RIC is a new network element that is defined in the Oran Alliance that is responsible for part of the radio resource management. The near real-time RIC is located, as you can see, inside the RAN, and for this reason it doesn't have access to the external information sources, as opposite to the non-real-time RIC.
Okay.
In addition, the near real-time RIC operates on the same time scale as other network elements, such as the CU, and for this reason it can create conflict. For all these reasons, Ericsson currently sees more value in the non-real-time RIC than in the near real-time RIC.
Well, in that case, let's get to the good stuff. So the non-real-time RIC, can you explain to us the design of that and the thinking behind it, perhaps?
Absolutely, Stan. Behind the non-real-time RIC is a set of underlying principles, and the first one is about information, access to information. So we see here that the non-real-time RIC can have access to real-time information from the RAN itself over this O1 interface. It also has access to all the information which is in the management system, such as configuration data, topology data, what goes on in the transport network, etc. And thirdly, we also can connect this to external information sources of any type, so you can have contextual information into the SMO, so it can be used by the non-real-time RIC. The second principle is that it can influence the behavior of the RAN, tell the RAN what to do, on a per UE basis. And that is important because each individual UE have its own requirements on the services, etc. And for that, we introduced the new A1 interface that can carry these information policies on a per UE basis. And traditionally, the management system has been rather slow. You reconfigure maybe every hour or day or week. And here we have sped things up, and the loop from gathering information, analyzing information, and sending policies down to the RAN can be done within a second.
Okay.
Fourthly, we have designed the non-real-time RIC for openness innovation. And you can see that the RIC itself consists of the RAPs up here.
Yep.
You have the platform down here, and there's an open R1 interface in between. And the RAPs are the guys responsible for the intelligence. They do all the magic stuff. The role of the platform is to support these RAPs with a set of services so they can do their stuff. And lastly, it breaks my heart to say this, but the man-made algorithms that I've been spending my careers on doing are getting beaten by artificial intelligence and machine learning. And for that, with that insight in mind, we have designed the non-real-time RIC to be native or from day one in an architecture that fits machine learning and artificial intelligence.
Future-proof. Okay, so to sum up, so it lives in the management layer, and it also has access to external information sources, opening up for new use cases. So it basically gives us a fresh breeze into our radio access networks.
Yeah, we think so.
Absolutely.
So you mentioned our apps. They seem to be a pretty important part of the whole solution. But, I mean, what are they?
The RAPs are just normal applications, but they run on top of the non-real-time RIC, and they have the potential of optimizing the RAN behavior, and not only the RAN behavior, but also the behavior of the other network domains. There may be different types of RAPs. For example, RAPs that are designed to create insights, for example, identifying all the drones that are connected in the network in a certain areas. And other type of RAPs that instead are designed for optimizing the RAN behavior by setting policies or by changing configuration parameters.
And can anybody develop them, you know? How's that, Eric?
Well, as we said, we developed the non-real-time RIC for openness and innovation. So in Oran Alliance, we standardize a set of services from the platform that the RAPs can use. Yeah. And by that, the RAPs know which information they can subscribe to and which policies and information they can send to the RAN over these standardized interfaces. So with that, since it's specified, anyone with a good idea could, in principle, build an RAP. And RAPs, they can also talk to each other. And to take one example, you could have one RAP which is really good at detecting video quality within a stream. And that information can be used by a second RAP that is aware of the operator's business intents for video quality and priorities, and which can use this information to then guide the RAN by telling the RAN what to do, and maybe give a little extra boost of bandwidth to users who may need it.
So we touched upon new kinds of use cases before. Which ones do you see will bring most value?
Well, the non-real-time RIC enables 3 new categories of use cases. The first one is RAN enrichment data, where the non-real-time RIC provides enrichment information to the RAN so that the RAN can optimize its behavior. For example, the weather conditions that we discussed at the beginning. The second type is enhanced self-organizing network functions. Using fast closed-loop automation, the non-real-time RIC enables new use cases that are related to SON functionalities, such as the joint orchestration of run, transport, and core for end-to-end service quality of assurance, that as we discussed at the beginning. The third category of use cases is user-level policies, where the non-real-time RIC can set policies per users or per user group. And I can expand a little more on this third category of use cases by showing one cool concrete example.
Perfect.
Let's assume that we have a large fire ongoing in a building and 2 firefighters that are active in the area. Each of these firefighters is streaming a live video through a camera on its helmet. Now, the first firefighter, firefighter 1, gets closer to the fire. At this point, its video becomes more important.
Of course.
Then let's assume that we have one RAP in the non-real-time RIC that is monitoring the quality of the video, and it also monitoring the location of the firefighters. Let's also assume that the RAP is aware of the fire location through the use of external sources. At this point, the RAP can decide that firefighter 1 that is closer to the fire needs to be prioritized. In order to do that, would set a new declarative policy. This declarative policy will be sent to the RAN using the A1 interface, so that the RAN can update its scheduling priorities and give higher priority to firefighter 1. As an outcome of that, firefighter 1 would see its throughput increasing, and therefore, the quality of its video would also improve.
Of course, that's very important. And do you see that the same kind of policy can be used for other scenarios as well?
Absolutely. It can be used in many other scenarios. For example, in private networks, let's assume a port where some of the ships need to be prioritized over others.
Excellent. So this has been a very eye-opening discussion, I must say. Now, as we're approaching the end, could we please try and summarize then what will the non-real-time RICs mean for the Cloud RAN?
Well, as chief architect, I'm really excited about that the industry moving towards intent-based management, programmability, and automation. And the non-real-time RIC that Ericsson and others are driving in Oran Alliance, the capability of use this contextual information to act in real time, to do the per UE, opening up for use cases that we have and the capabilities that we haven't seen before is really exciting. We think that it will bring a lot of value to our customers and to the industry.
And speaking of customers, for the service providers, what will it bring?
Service provider can benefit from this type of innovation and all these new use cases, no matter what RAN infrastructure they choose to use, purpose-built or cloud native. And Ericsson stands ready to help and guide our customer as they embark on this journey.
All right, I'd like to take the opportunity and thank you both for coming to our show and unveil this for us.
Well, thank you, Stan.
Thank you, Stan.
Thank you very much. And you guys, thank you as well for watching this episode of the Tech Unveiled. I think we all learned a new name today, the non-real-time RICs. So if you want to discover even more on that subject, you can, of course, as usual, go into our blogs and read up the full content. In the next show, we are going to discuss the network management in Cloud RAN. So until then, take care and goodbye.